The 7000 triple quadrupole GC-MS is the first quadrupole MS-MS system designed specifically for the unique requirements of gas chromatography applications. These requirements include enhanced selectivity, consistent low detection limits, and robust day-to-day operation. The typical MS-MS description focuses on the extraction of ions from the source, isolation of the precursor ion in the first quadrupole, dissociation of precursor ion in collision cell, and mass filtering of the product ions in the second quadrupole before detection. But let's return to the ion source to discuss processes that are often overlooked. Even for a high-performance source, ionization efficiency as a percentage of molecules entering the source is very low. This means there are many more neutrals than ions exiting the source, so a thorough description must include analytes neutrals and ions, helium neutrals and ions, column bleed neutrals and ions, and many more neutrals and ions from the matrix at concentrations typically higher than the analyte. To simplify the description, let's start with the analyte molecules and ions. Analyte molecules enter the vacuum source from the GC capillary column and begin bouncing off the hot surfaces of the source. Analyte ions are immediately extracted from the source and focused into the quadrupole mass filter. But what about the non-ionized molecules? The electrical fields within the MS have no influence on these molecules. They follow rapid random motion until removed by the vacuum pump. Parallel processes are occurring simultaneously for the molecules from the sample matrix, and instrument background like column bleed. The quadrupole analyzer performs the critical task of mass filtering to isolate the analyte's ions from the majority of these ions. Chemical noise often remains after the first quadrupole, but the selectivity of MS-MS removes this final source of interference. Again, we ask, what about the large population of non-ionized molecules? Although the turbopump removes many neutrals quickly, some will randomly diffuse into the quadrupole. At the end of the GC separation, the EI source will be flooded with the highest boiling molecules from the sample matrix. Even in a vacuum, these high boiling molecules can contaminate surfaces in the mass spectrometer. A cool surface will accelerate this contamination process. As we think about the potential for contamination, we must not forget helium. The intense flux, high flow of helium ions helps to burn the high boiling molecules onto the surfaces of the source and the analyzer. The cooler the surfaces, the faster the rate of contamination, and the faster performance is lost. For an LC atmospheric pressure source like ESI, metal quadrupoles at temperatures of 100 degrees Celsius are perfectly adequate and commonly used. But for GC-MS-MS analysis, metal surfaces at this temperature will quickly become contaminated. The Agilent 7000 uses a combination of proprietary and patented technologies to avoid contamination problems and ensure robust, high-performance operation. These include an inert source operating at up to 350 degrees Celsius, and quartz quadrupole operating at up to 200 degrees Celsius. With 35 years of MS experience, Agilent built the 7000 around the unique hot quartz analyzer of the MSD, not the cooler metal quadrupole rods used for LC-MS-MS. Before continuing to the collision cell, one more process must be mentioned. An EI source produces a large number of highly energetic metastable helium atoms. These highly energetic atoms follow a random path like any other neutral until removed by the pump. Some will follow a path parallel to the analyzer and have a high probability of traversing the entire analyzer assembly to the HED-EM detector. During the development of the 7000, Agilent engineers realized a small flow of helium added to the nitrogen collision gas was very effective way to reduce the transmission of metastable helium through the collision cell. We call this patent-pending solution helium quenching. A comparison of signal-to-noise ratio with and without helium quenching shows the benefit of this technology. Helium quenching has no effect on product ion signal, but the neutral noise component is reduced by a factor of 4. This technical breakthrough means lower limits of detection and quantitation. The 7000 MS-MS, an MS-MS system optimized for gas chromatography. From the classical distribution of ions produced in the inert, high-performance source to the precise isolation of the precursor ion through the path of the hot quartz hyperbolic quadrupole into the high-pressure hexapole collision cell for efficient precursor dissociation, product ion transmission and simultaneous reduction of metastables with helium quenching, to the final accurate mass analysis in a second hyperbolic quadrupole field before ion collection at the triple-axis detector. 7000 system has been carefully designed to deliver robust sensitivity and reliable quantitative results. The Agilent 7000 Quadrupole GC MS-MS system, an MS-MS optimized for trace analysis of your most complex GC samples, the new standard for GC MS-MS performance. Agilent Technologies. Our measure is your success.